Hello students, so from this video we are going to discuss the 2 marks question which came in GATE 2014 paper mechanical branch. Okay, so let's see that question number 26. An analytic function of a complex variable z is expressed as, this is a general form of a complex function where iota I is root over minus 1. So if u, actually here w, it is wrongly written, it is u actually. Okay, so if the real part of a complex function is x square minus y square, then the expression of the imaginary part. Okay, and where c is the constant in the options. So this fz is an analytic function and you have to find out the imaginary part, you have the real part. So we know uh, if the function is an analytic function, it must satisfy the CR equations, Cauchy-Riemann equations. So del u by del x is equals to del v by del y. This is not del xy, this is del y actually. And del u by del y is equals to minus of del v by del x. Okay, so by substituting, if you will differentiate u with respect to x and u with respect to y, so you will get the answer. V is imaginary part is 2xy plus c. So the option C is correct. Okay. Let's see the next question. Consider the two solutions x1t and x2t, okay, of a differential equation, this one, such that x1 is equals to x1 of 0 is 1 and dx1 of dt at t is equals to 0 is 0, x2 of 0 is 0 and dx2 by dt of t equals to 0 is equals to 1. Okay, so you have to find out the Wronskian of the Wronskian basically. Okay, please also remember what is a Wronskian. Sometimes in different exams you will get directly the Wronskian. Here actually the definition of Wronskian is also given. Okay, so please see what is Wronskian and where it is used. Okay, so let's see, let me tell you how to solve this. Okay, so basically if you will find out, this is the differential equation given, so you can easily find out what is the auxiliary equation. Okay, if it's like d square plus 1 or m square plus 1 is equals to 0, so you will get the values of m as plus minus I. So after writing the complementary solution of this differential equation xc, you will get this. Here no particular solution is there, xp or yp in general. Why? Because the right hand side of the differential equation is 0. Okay, so general solution you will get complementary solution plus particular solution. So particular solution is 0, so you will get this complementary solution as general solution itself. And after putting the values, initial values, you will get you can also find the values of C1 and C2 also. But if it is not required, why? Because you have to find out the Wronskian. So we know x1 of 0 is 1. Okay, so x1 of let x1 yeah, you can do in this way also. Let x1 of t is equals to cos t and x2 of t is sin t. So we have taken this function as x1, okay, and this function is x2. Okay, so we know x1 of 0 is 1 and x2 of 0 is also 0. So after substituting the values in the Wronskian, you will get we have to find out at t is equals to pi by 2. This is actually pi by 2. Okay, so at t is equals to pi by 2, cos square t plus sin square t is 1. Not at t is equals to pi by 2, at any t. But if suppose you get a Wronskian in terms of function of t, so you have to substitute t is equals to pi by 2 at the end and calculate the value, what will be the Wronskian. Okay, so this was the question, very easy question. Now let's see the next question. These questions are of 2 marks each, so please be careful. Question number 28. Okay, this is a question from probability and statistics. You have to find out the mean and variance. Actually, a machine produces 0, 1 and or 2 defective pieces in a day with associated probability of 1/6, 2/3 and 1/6. Okay, So you have to find out the mean value of the and the variance of the number of defective pieces produces by the machine in a day. Okay, so we know if the number of defective pieces is 0, the probability is 1 by 6. If 1, then 2 by 3. If 2, then 1 by 6. So we know the the formula for mean. It is ex, it is denoted by ex, which is equals to summation of x into probability of x. Means if the number of defective pieces is 0, then what will be the probability of that number of defective pieces? Okay, so 0 into 1 by 6. So by easily calculating this calculation, you will get 1. Okay, now what is the variance actually? Okay, so we know the variance is mean e of x square minus mean complete whole square. Okay, so you have to find out the e of x square, so that's why we have calculated here, which will be 4 by 3, and after substituting the value you will get easily 1 by 3. So this is actually, if you remember the formula, you will be able to solve. Okay, there is no tricks behind this question. Okay, so let's see the next question. The real root of the equation this is equals to, up to 2 decimal accuracy is, you have to find out the real root. Okay, so here actually this question is not a direct question. You have to find out the real root. So before finding the real root, you should find out the range at which the real root is lying. So if you will substitute 0 in this function, you will get negative value. If you will substitute 1 in this question, you will get positive value. So it's clear that the root is lying between 0 and 1. Okay, so you are easily, or you are able to find out the range of the root. Okay, so if you want to find out the real root, you should use Newton-Raphson method. Why? Because it is the quickest method to get the root. Okay, so by using the Newton-Raphson, you should know this formula, and the function the function is this, fx minus 2 cos x minus 1. Okay, so let x naught is equals to 1 radian. Okay, why 1 radian? Since the values lies between 0 and 1. So if this is the Newton-Raphson formula, so xn plus 1, if you will substitute f of xn and f dash of xn, you will get this expression. Okay, so substituting n is equals to 0 means x naught is 1 radian, you will get this answer x1, x2, x3 in this way. Okay, so the range given in the answer sheet was 0.53 to 0.56. So any answer is correct, since after every iterations it will be like proceeding towards the exact root. These are actually the approximate root. Okay, fine. So this is the answer. Now let's see the last question for this video. A drum brake. This is a question from belt and ropes kind of thing, or a drum or a brakes chapter from machine design actually. Okay, so you can study this as a machine design. In machine design also you can study this topic in theory of machines also. Anywhere you can study. So a drum brake is shown in the figure. The drum is rotating in anti-clockwise direction. Okay, the coefficient of friction is 0.2. You have to find out the braking torque in Newton per meter, Newton meter. Please be careful by the units. Okay, so just you have to take the moment at this hinge. Okay, pin joint. So you can easily take the moment 1000 into 0.8. Here one normal reaction will be there, as well as the friction force. So friction force value will be equals to mu Rn, since it is a dynamic case. Okay, so Rn into 0.48 plus mu Rn into 0.1. All these dimensions are given in millimeter, so I have already converted them into meter divided by 1000, so you won't face any problem. So once you can calculate the Normal reaction, so friction force into radius of this drum